All right, welcome. This is going to be our very first presentation that I'm going to record for you. And again, we're going to use this as our little test experiment, right? So remember in class I was telling you my idea was I can make you guys these videos, there's short segments, and you can watch them when you want. And they're also going to be labeled so you can find them easier and more effectively. Now, again, some of you may want the lecture conversation. Other people may want this one where we can then use our class time to conversate and then dig deeper. It's totally up to you. But again, no, we're going to take this experiment and you're going to tell me which one you like. All right, so let's get started. What I'm going to do is I'm going to teach this first lesson again because that's where we started, and I'm going to finish this whole chapter here in a bunch of truncated segments. All right, so ready? Here we go. So remember, we have to learn about chemistry. Chemistry is the basis of human anatomy, all right? I mean, regardless of how deep your chemistry knowledge is, there's going to be chemistry throughout every section we talk about in this class. So instead of going straight into dissecting and all this other stuff, what we need to do is we need to get a nice basis, a nice ground to hold ourselves up on, and that's what the chemistry is. It's going to take part of everything we talk about, so let's get our basics out of the way so you'll have at least a simple understanding of what we talk about when we go into the more complex areas and deeper into chemistry, okay? So a couple synonyms that you guys are going to need to know, and I kind of wrote these out for you, and if you wanted to take notes, yes, usually the bold ones are important, but everything on the side of it are not really you have to write. Those are like my interpretations. You don't have to write them verbatim. Remember, whenever you write notes are for you, they're not for me. So whatever you need to understand it is what you need to write, okay? So for example, mono means one, and I could have left it at one. However, I put uno, hana, ich, etc. Why? Uno is one in Spanish, hana is one in Korean, and ich is one in Japanese, right? So, it's just conversation, we can talk about that. But overall, mono is one. So when you think of a monocle, like the Monopoly guy has that little monocle on his eye, right? Etc., etc. If you love music like I do, mono sound is not great because sound comes in at once. Stereo is like two sounds rotating, and so it gives the illusion of depth. So mono is one. Di or bi is two, like bicycle is two wheels, right? Bifocals, two glasses that help you focus, right? Tri, of course, like tricycle is three, right? And then we're going to talk about triglyceride, so pretty easy, it's three glycerides. So once you figure out what a glyceride is, there's three of them. Okay, then we're going to talk about poly, which is many, right? For example, polysaccharide, many saccharides, and that's just sugar, right? There's going to be like polymers, which is just many molecules, etc. Okay. Macro and micro, you probably remembered from basic biology, right? Micro from a microscope, you're looking at small things, and macro looking at larger things. Okay. So again, we're going to just review. We're not going to go in depth. We're not going to spend a lot of time on extra things that you would learn in chemistry class. That's not this class. So I'm going to only focus on, again, the overview of what you have to understand for this class. So, a molecule versus an atom. Again, an atom we talked about when we had our conversation was like those single things you see on the periodic table, like helium, oxygen, and all that. They're singular, right? Molecules is when you put two or more atoms together and you make something. For example, right, we don't call it, hey, did you get that what do you call it? The atom of water, right? We say, did you get the molecule of water? Okay, then what we also have moving forward, right? So we have a molecule of water, right? We have a molecule of carbon dioxide. We do not have a atom of water or atom of carbon dioxide. Okay, I'm not repeating, but my pen wasn't working and I got it working now. So, all right, moving on. So then we started talking about this big sentence and a couple sentences here, and I said, hey, don't focus on the whole thing. Let me explain the terms for you, okay? Because the terms are more important of how they come together versus just gibberish that don't make sense. And the first thing that we approached was this term valence, right? And I said, you know what? There's a great definition in your book. And if you've taken advanced chemistry, of course, it's much more specific. But again, We need simplicity for our class. We just want you, and if you are not going to be a science person, that's fine, but at least you understand its function. All right, so let's just go, and I'm going to skip a few slides because I'm going to come back to explaining it. Okay, the things that we have to explain to understand valence is you're going to have a general knowledge of these guys, which all of us probably had in regular science course, where we heard of a thing called a proton, a neutron, and an electron. Okay, now a proton, again, these guys are positively charged particles. We will talk about these guys later, and very, very small. I mean, maybe one chapter. Okay, neutrons, they're neutral, and for the chemistry people, they might want me to mention it, but other than that, we don't use them in this class. However, for chemistry, you need to know what a neutron is, and that has a neutral charge. What we'll be using a lot of, and I mean a lot, is understanding these bad boys called electrons. Oops, I scribbled over it, but whatever. All right, so anyway, let me see if I can erase that. Okay, nope. All right, so an electron is an E minus, okay, and this is going to be like a shorthand for it. What does that mean by shorthand? It's like instead of writing electron out a lot, anytime you see these E minuses, it means that there's an electron floating around somewhere. Okay. Where it also says that it's very small, that's a great point, but not important. I'm never going to ask you for the memorization of its mass. Just know it's small. Okay. All right. So anyway, this here, a lot of you have had basic chemistry, and you had to learn the orbitals. Again, that's for chemistry. I'm not going to be a chemistry teacher for you. I'm teaching the basics, so we're not going to go over that. I'm going to teach it a simpler way that I use to remember for myself. Okay, these guys on the far right, we remember them as, noble gases. Okay, I'm pushing the wrong button. All right, noble gases. And these noble gases have a very unique property. They are extremely stable. These guys are all the stable guys, right? And the way I like to, if I had to, and I always try to pretend I'm explaining this to like maybe a business person or somebody going into law. They don't need to know the super in depth about the orbitals, right? They just need to know the understanding of it to get the idea so they can understand how their body is functioning. So I like to remember it as happy. Very simple. Everybody knows what happy is, right? Okay, so the molecules want to be happy. In English, they want to be stable. So what they want to do is, this fluorine, for example, right here, he is one spot away from this side, which means if you take a look right here, he is missing something that he has. That something is that electron I was talking about. So what happens is he needs one valence electron. He needs to share this electron with somebody else to complete him. Once he's complete, he will move over, and now he will join this little happy crew over here, right? These little happy guys. Okay, great. Now, same thing. Oxygen is 2 spots away, so he needs 2 valence. He needs 3, and he needs 4. 1, 2, 3, 4. Okay, so now what's confusing if we had a periodic table on the screen, you would actually notice that it's organized kind of like, actually I'll just erase this and make it easier so you don't see all that, right? It's organized like this, bam, right? And get this little, so when I say, well, how many electrons does hydrogen need to become on this happy side with helium? Now, sometimes people would want to count these, but that's why I drew that box in for you. That box is signifying that this is an empty space. There's nothing there. So in actuality, it jumps, and it only needs 1 electron to be stable. Okay? Very important, because hydrogen is used for a lot of things. So now, what we're going to talk about is, well, what is this purpose and what does a valence mean? And we're going to practice it in class, but again, today is for understanding. So, what I wanted you guys to do in class is if you can write HONC, H-O-N-C, which is hydrogen, oxygen, nitrogen, and carbon. Hydrogen is 1 molecule, one valence electron. Oxygen has 2, nitrogen is 3, and carbon has 4 valence electrons. What does that mean? It means if I had the most common molecule that all of you know is H2O, oxygen, sorry. All right, oxygen here. Oxygen needs 2 bonds. He needs to share with somebody. So what we do, we had a hydrogen here. And then the hydrogen will share this little line is signifying that's an electron sharing between them. And over here will be another hydrogen and electron sharing between them. Now this sharing here completes their orbitals, or aka, they're happy, they're stable, they're content. English. How many lines does this oxygen have? If I erase this, right, and I make it just without all that other stuff on the screen, how many lines does it have? Well, I have one line here and a second line here, which means I have one electron here, which means if I had my honk, right, my oxygen had 2. So he is pretty much happy, right? What about the hydrogen? How many does he need? Well, he needs 1. So he has one line only connecting to him, right? He has one line only connecting to him. Thus, these are stable as well. So they have their little check marks and check marks. So they're pretty much all happy. That's why water is a very stable molecule. Okay. What about another one? Easy. Well, if we're using honk and carbon equals 4, carbon dioxide. All of you are breathing CO2. Okay. So what happens? Carbon, right, needs 4 and oxygen needs 2. But let's say I did this. Are they happy? No. They're not, right? Because remember, oxygen in honk needs 2, but he only has one line. He only has one bond sharing that electron, same with this guy. And remember, carbon, he needs 4. So this definitely is not a stable molecule. However, if we create a double bond here, now this oxygen has 2 bonds connecting to him. Thus, he has 2, he's stable. He has 2, he's stable. How many lines are connecting to this carbon in the middle? He has 1, 2, 3, 4 lines, and he is stable. So, what does this mean? Okay, so like I promised, I'm going to go back and forth between the slides. Cause it doesn't need to be in order, it needs to be in understanding, right? So the order of the slides doesn't matter. I'm going to go back and forth for your understanding. So this term valence is with those honks, right? With the how many electrons can we share, can they be put together, and how do they work, right? And then I said they form some sort of bond, and I drew like, right? And if I had my oxygen and my hydrogens, right? I drew, let me erase that, right? I had my oxygen and hydrogen. I have these little lines here. Those lines, whenever you see a solid line in any picture, for example, this picture here, every one of these lines, right? Each one of these lines is a covalent bond. Okay, so let me erase that. Go back here. So it said, right? We went over valence, and if you don't know, again, I can help you later, right? But it says that it will need 4 covalent bonds. Hey, the 4 links to the valence that it wanted, and the lines I told you about are covalent bonds, which means, what's a covalent bond? Okay, so let's skip all this. Okay, so now it's not on this screen, but I'm gonna write on here because oh, actually it is on the screen, sorry. And I'm gonna write on here on top of it. Again, we have a whole bunch of bolded words. Please write what's meant for you, not what's on the screen. Your interpretation of understanding is more important than my writing of stuff. Okay, so I'm not going to talk about ionic bonding right now. I'm going to talk about this covalent because that's what we're speaking about. Now, this is true, and I told you the electrons are going to be sharing between the atoms, right? So remember, this oxygen is sharing, and that's why I drew this picture here. This electron is shared between the oxygen and the hydrogen. This other one is shared between the oxygen and the hydrogen. Okay, great. So, now what? Well, let me erase this. Okay. There's more to this. So I'm going to actually erase this, and I'm going to write more with my nasty handwriting, but, you know, it is what it is. I got a trackpad. All right, here we go. So we know covalent bond, right? They are, and I will tell you, but that didn't work. Okay, don't cross it off. Again, it's a trackpad. Give me some slack here. All right. All right. So we got a covalent bond, and this guy here, he is sharing an electron, right? He's sharing an electron. We got that. Okay, that was what you wrote earlier. But there's more to it. A covalent bond also is the strongest bond. Okay? He is the strongest bond. Okay? What does that mean? Well, if you look at my arm, right? And my arm is attached to my body. Kind of like the oxygen is attached, it's physically attached to this hydrogen, just like my arm, and there's a line attaching to my hand, right? Okay, good. All right. So now, I'm going to finish this just to be correct. It's the strongest bond, but why? Is because they're physically a part of each other. Now, I could break it. One of you could easily use something to rip my arm off. But it requires something in science, and all of you is like strength and all this other stuff, which is true. But it requires in science what we call energy. And it's the same thing. To break this bond here, I require a lot of energy. So, to break these bonds require a lot of energy. Because it requires a lot of energy, we call it strong. Pretty simple, right? Okay, so the next one was ionic bond. Okay, oops, that's a C. Bond. So an ionic bond, let me make this line here well, is not a share. Oh, okay, you got the other one. All right, I'm still learning how to use this trackpad, so give me a second here. All right, so ionic bond is not a sharing. What an ionic bond is a giving or receiving. All right, giving or receiving of an electron. Well, what does that mean? Okay, now I'll come back to this, but there's more to it. Okay, so I'm going to fast forward a bit. I'm going to show you a picture to make more sense of it. I like pictures. Okay, so here we go. Take a look at this guy, right? Right now we talked about carbon, we talked about nitrogen, we talked about oxygen, we talked about hydrogen, honk, right? And we talked about everybody wants to be one of these bad boys right here, okay? Now, here we have chlorine. It is a dangerous gas. You breathe it, you will die, okay? It's not a good stuff. And then on this side here, we have sodium. Sodium is a metal. You wouldn't be eating it. It's nasty. It's a metal. Why would you eat it, right? However, when you mix sodium and chlorine together, you have a wonderful chemical that you put on your French fries, you put on popcorn, right? It's just salt, right? It's just salt. So how do I mix a poisonous gas with a metal, making something you sprinkle all over your French fries? Well, that's why. It's because of stability. Take a look. Remember, he only needs one spot to move away to be in this little happy zone, right? The stable zone. This guy, he has to move all the way across all this. He doesn't want to do that. That's just too far. So what does he do? He's smart. He's like, hey, why move that far when I got one guy I can just give away? What if I give this guy away, right? And chlorine takes it. He is happy now because he moves over to the little stable spot. He is happy. Sodium is happy now because now sodium will actually move up to the spot here, and now they are both in this little happy land. However, something happens when they do that, because remember, and I'll erase the screen here. Electrons have this is why I said a very important, a negative charge. Okay, so because it is a negative charge, okay, what happens? Well, here's the same picture again. I got an electron here, and I'm missing one. But if I give mine away, and then he takes it, right? I give away a negative. If I give away a negative, that makes me more positive. If I am 0 and I take a negative, I become more negative. That is why you see the positive and the negative here. So what happens now? Well, the luxury of being in class is I have these water kits, and they're magnetic, and they're really cool because what happens is, if I try to put, and I'm going to use Post-its because I don't have the magnets here, if I try to put these two blue guys together, right, they hate each other if they were magnets. Magnets that are the same polarity hate each other, right? Pluses hate other pluses. Minuses hate other minuses. However, if you ever find a plus and a minus, they love each other. They are attracted. And in fact, this is how magnets work, and they'll be pulled in together. Okay, this wasn't a good idea. I'm not going to use those post-its. Okay, so they're attracted to each other, causing that bond. And that's why if you take a look at this picture here, you see that there are this representation of these three lines, which would actually be three dots. That is different than drawing this, isn't it, with oxygen and a line. Remember, the line is a sharing, and it's like my arm. It's a strong bond, right? I can't break it. Well, I can, but it takes a lot of energy. That is not attached to it. That is like me attracted to these post-its. Now, I'll hold them because my positive hand is attracted to the negative, but what is easier to break? Is it easier for me to pull out the post-its of your hand, or is it easier to rip off your arm? Self-explanatory. I was like, what? Of course it's easier to pull off the post-it because it's a weak interaction and they're not a part of each other. However, if you are an electron that is shared, you are a part of each other, becoming each other, thus requiring a lot more energy to break the bond. Okay, so I know my handwriting is sloppy. I'm getting used to this trackpad writing, so bear with me. All right, so here we go. I'm going back to this. Okay, so ionic bond, again, is the giving or receiving an electron. That's the pictures I showed you. If you are having a confusing time, please go back, review that, and if you still have questions, I'm always there in office hours or in class. Feel free to ask me. Okay, we're still not done with ionic bond, by the way, but there's still a little bit more. Now, because I gave away or received, I'm just going to put REC because don't have a lot of space here, the electron, what happened again? I became positive and negative. Now, this here causes an attraction between them, which is, oh, how come it's not working? Attraction. Okay, now this is what causes the bond, the plus and the minuses. Okay, so now real quick, the plus and minuses has a name, and I always remember this. I always remember the North Pole and the South Pole. One is plus and one is minus. Okay, well, if this is called polarity. If there's a positive and minus, we have a polarity. We like polarities, pluses and minuses, okay? So, my sloppy handwriting, but you get it, right? Giving and receiving of an electron, because I gave away or received the electron, it causes a plus and minus charge. That is called polarity, which then will cause an attraction, aka they're stuck together like magnets. Good. Now, I'm going to erase this. If you want to read it, just pause it. Okay. All right, now the last bond. So we have covalent. Ooh, wrong button. Let me write that again. Covalent. That is strong. I'm just going to do shorthand, right? Actually, you know what? I'm going to do it a better way for you. I'm going to do covalent, right? I'm going to do ionic. And I'm going to do the last bond, which is hydrogen. We call it hydrogen bond, but again, if you're going into full IB bio, or IB chemistry, you also have to know the guy's name of van der Waals forces, right? So it's 2 A's forces, okay? Van der Waals forces. I'm just going to write that because I just don't have space, as you can tell with the crookedness here. Okay, so anyway, covalent, ionic, and hydrogen bonds, okay? So let's just do the first one, strength. Covalent is strongest. This is like the medium, and this is the weakest, and I'll explain why in a moment, okay? Second, what is the definition of a covalent bond? A covalent bond is the sharing of a what? Electron. Okay, sorry. All right, now this one, what is, let me draw a line here. Okay, what about ionic bond? That is they give receiving of, oops, how come it's not working? Here we go. Receiving of an electron. This causes, maybe I can't put my hand on the board. There we go. Causes plus and minus, which is an attraction. Good. Okay, I'm having technical problems here with my pen, so give me a second here. Okay, attraction. Okay, hydrogen bond is very different. Hydrogen bond, you don't give anything. There's no giving. There's no receiving. You are already, why is this slight? Oh boy, this is bad. Slightly positive, and you are slightly negative. Okay, what does that mean? What do you mean you're slightly positive and slightly negative? It's pretty much with water is an example. Okay, so normally what happens is water, or O and hydrogen, right? Okay, and remember, this picture is the same as this. Now you cannot see that there's a line between here because it's a different interpretation of the picture, but that's what it is. Okay, now remember, what's not seen here is this little electron here that's being shared. Because of that, and if you look at the size difference, look how much bigger oxygen is than hydrogen, right? It's big, right? This guy looks like Mickey Mouse ears. Okay, so what happens? Because the oxygen is bigger, it has a more slightly negative charge because it's just bigger. This one will have more of a positive charge because it is smaller. So what happens is that these guys will go around and attract to each other. All of you guys hopefully have washed your car, right? You ever notice when you're washing a car and you're drying and you see that little bitty drop hit one water and it boom, magically poof, gets bigger and it becomes one uniformly, and it grabs another one and it compounds and keeps getting bigger and bigger and bigger as it goes down your car, growing. But the key part, as soon as they touch each other, they absorb and they become each other because they're like magnets. That's what's attracting them. And that is why in hydrogen bonds we draw them as dots. And you will see that it has this negative and positive here, which charges it. That's also why, if this is negative and this is positive, right, another oxygen will never come in and attach to this oxygen. They hate each other because two negatives. So they always align appropriately. Okay, so I'm going to go back to my sloppy handwriting. We're almost finished for the section 1. Well, the first thing here, okay? I'm going to rewrite the hydrogen bond, but you got the idea, right? I don't know what happened with the pen here, but I'm going to rewrite this hydrogen bond for you guys. All right, so here we go. All right, so the hydrogen bond. All right, we know he is the weakest. So if you want to put him and fix that there in your little chart, I like that little chart. It makes it easier to remember and see it. It's the weakest bond, right? The hydrogen bond is the weakest. And why is it the weakest? It's because, remember, it is the molecules are already, oh, this could be fun, already plus and minus. What does that mean? They already have the charge. I did not give, I did not receive. You already are slightly positive. You're already slightly, very little, slightly positive or slightly negative. Because you are slightly positive and negative, this causes the same as before. If you're plus and minus, causes an attraction. And what is this attraction? That is a bond. An attraction is just a bond between them. Let me fix that D here. All right. How do we draw them? Okay. So a hydrogen bond is drawn with these dots. Okay. Ionic bond is drawn with these dots too. So the question is, well, if ionic and hydrogen bond are drawn both with dots, how do I know the difference? Well, here's what's good. Most of the time, like almost all the time, it's a hydrogen bond. If there is an ionic bond, 9 times out of 10, it will tell you. For example, in When you learn about proteins, there's an ionic bond in one of the in the sulfur bridge, not the sulfur bridge, in the in the disulfide bridge, in the tertiary structure. English, I'll tell you when we get there. However, it's marked on there. It will say, quote, ionic bond, and then show you the dots. So what I'm trying to tell you is, you don't have to memorize or look for key things. It will tell you, here is the ionic bond 9 times out of 10 in most books. So if you don't see anything marked on it, assume that it is a hydrogen bond. Okay? What was a covalent bond picture represented as again? Okay? And here is your hint. And then we can go back and look at that picture one more time. Lines. Remember, covalent equals lines. Anytime you see a solid line. So the next time you watch a video on COVID and here's a picture of the virus and how it works, you see all the little dots, hydrogen bonds in the DNA. And you see all the lines, protein structure held together by covalent bonds, which is what a virus is, simply protein and DNA. So, let's go back to the confusing words, and we are done with our first video, video 1. Okay, carbon does what it does because of chemical properties. It has 4 valence electrons. This means it doesn't form ionic bonds, but rather covalent bonds. English, what's a covalent bond? Shared. What's an ionic bond? Giving and receiving. It is not a hydrogen bond, which is weak interactions between positive and negative charges. All right, which means this: if you were absent the first day of class, this is everything we did. If you forgot what we did first day of class, this is what we did. This is our sample. I'm going to make the next video shorter. This video was long because we already did this in class. So I just wanted to cover everything we did in class in one video. Hope it was okay for you guys, and I will see you in the next video. Have a good one.